Bismillahirrahmanirrahim. Welcome dear students to the platform of Quanta Publishers. This is lecture series Teach Yourself, and today our topic is about the rectangular components. The components which are perpendicular to each other are called the rectangular component. Here we will consider a vector A represented by the line OP, and in the next figure you will see that diagram, and then we can resolve this vector into its component like ax, ay, and az. Here in this diagram you will see that here is a vector from the origin A to the point P having a components ax, ay, and az, and this vector A from the origin in 3 dimension makes an angle alpha with the x-axis and the angle beta with the y-axis, and then make an angle gamma with the z-axis. So these are the three angles alpha, beta, and gamma made with the x-axis, y-axis, and z-axis. And if we want to resolve this vector into its perpendicular component, then we have to draw a perpendicular from the head of this vector to the basal plane like xy plane. So we have draw a perpendicular on the xy plane at a point Q. Here you see that the ax, ay, and the third component az is equal to 0. So here you see in this diagram that another vector formed from the origin, that is OQ. And now if we want to resolve this vector OQ into its component, then draw a perpendicular line on the x-axis or either on the y-axis. So we will get the two component AX and AY. By using this geometry, we can write its equation as the vector A is the sum of the two vectors. First vector is OQ in the basal plane xy plane, and the AZ component that is perpendicular to this xy plane. And by using this geometry, we can also write OQ vector, and that OQ is the sum of OR and RQ. In the above diagram, you will see that OR is along the x-axis and is denoted by the vector AX, and whereas RQ is along the y-axis and is denoted by the vector AY. So we can write it as OQ is equal to AX plus AY vector. So resultantly, by plugging this equation over here, we will have the vector A is the sum of vector AX, AY, and AZ. So this is the final equation for the vector A into its component AX, AY, and AZ. Let us see over here, we can write the vector AX into its specific unit vector, because AX is along the direction of x-axis. So we can write it as the magnitude of vector A in the direction of x-axis, the unit vector chosen as I unit vector. Similarly, we can write AY is equal to AYJ, and AZ vector can be expressed as AZ and K unit vector. So by using these components, we can write them as vector A is equal to, here is the vector AX, and it can be expressed as AX into I unit vector and AY into J unit vector and AZ into K unit vector. If you want to find out the magnitude of this vector, then we have to take the sum of the squares and then their square root. And in order to find out the direction cosines alpha, beta, and gamma, so we can write them as, here you see the vector A can be expressed as AXI plus AYJ plus AZK, and the definition of unit vector is the vector divided by its magnitude. So if we replace this vector A over here, we will have AXI plus AYJ plus AZK divided by the magnitude of vector A. If we separate this magnitude with each component, so we can write them as AX divided by A, AY divided by A, and AZ divided by A in their respective direction I, J, and K. Now we can replace AX divided by A with the factor cos alpha, and similarly AY over A can be replaced as cos beta, and the AZ divided by A is replaced as cos gamma. If we replace these values by these factors, so we can express the unit vector A is equal to cos alpha I plus cos beta j plus cos gamma k, whereas the cos alpha, cos beta, and cos gamma are called the direction cosine of this vector A. And if we replace these direction cosine with some letter, like cos alpha is replaced by letter L, and cos beta is replaced by M, and cos gamma is replaced by N, then unit vector A is written as, here you see that unit vector A is equal to L into I plus M into J and N into K. So in order to find out the magnitude of this unit vector, we can write them as the sum of the square of its components, L square plus M square plus N square, and the whole square root. We know that the magnitude of unit vector is equal to 1. So on left hand side, you see that here is 1 is equal to square root of L square plus M square plus N square. By squaring on both sides, we have the final equation L square plus M square plus N square is equal to 1. So the result over here is the sum of the square of direction cosine is equal to unity. Thanks for watching. We will meet in the next lecture.